second group here. Today we are going to present about describing test result. Our group's members are Miftahunajah Aditiya Pratama, Yosia Ismail, and me, Nabila Tasyaa. Describing test result. The purpose of describing the test result is that to provide the test developers and test user with a picture of how the student performed on it. To show tester statically describe the test result, 4 different types of skills can be used to organize numerical information. Then the several ways of visually displaying sets of data with reference to the frequency of each score will be illustrated in this opportunity. There are 4 measurement scales such as nominal, ordinal, interval, and ratio. The 4 scales are useful in one way or another, in which they represent 4 different ways such as observing, organizing, and quantifying language data. Nominal scale. A nominal scale is used for categorizing and naming groups. It could be simplified be called as labels. Nominal scales are for labeling variables without any quantitative value on it. Some of the most common categories or grouping are according to gender, nationality, native language, educational background, level of language study, and so on. A good way to remember is that nominal scale are kind of a scale that represent names or labels. Ordinal scale, ordinal scales. If the data if the data are arranged in order or labeled in order numbers such as first, second, third, and so forth, the data are on ordinal scales. Ordinal scales is the scale that orders or ranks. So each point on the scale is position that is more than or less than the point on the scale. With these scales, ordinal scales, the order of the value is what important and significant, but difference between each other is not really known. Take a look at an example. In this case, we know that fourth better than third and second, but we don't know about how much the better it is. For example, it is difference between okay and unhappy, or the same case as the difference between very happy and happy. We can say ordinal scale are typically measurement of non-metric concept, like satisfaction, happiness, and etc. With ordinal scales, it is the order that matters. Interval scale. Interval scale is a scale that data that presents the order of a number, the order of a name group of the data, but it provides additional information. As its name implies, an interval scale also shows the interval or distance between the point in that rankings. Okay. Consider the score that's shown in the table. The students can be categorized into 4 groups such as top, upper middle, lower middle, and lower groups. On the nominal scale it is, but in the context of the ordinal scale, the students can be also ranked as shown in the table. And then, however, the scores themselves provide much more information than either of the other score scales, because the interval scale provide and indicate the interval or distance between the students' score on the task. And in the context of the language test, Interval scales can be in the placement task, or proficiency task, achievement task, or diagnosis task, as well as the skills. The skills can be used to measure attitudes, learning styles, and so forth. Then ratio. A ratio scale provides additional information too, beyond the ordering of data and distance between the points. It has a zero value, and points on the scale are the ratio of the other points. However, claiming that someone knows the zero of a foreign language is difficult, because knowledge of a native language provides some understanding of language in general. It is also a claim that the students who score twice or with another. And ratio scale relevant to language teachers include age, years of schooling, and language study, and number of the language spoken. Displaying data. Frequency. In displaying data, the point is that frequency is a useful tool for summarizing the data and revealing patterns in nominal scales, and it can also be used to convert to interval score into nominal scales. Frequency can be displayed in frequency distribution table, which shows the frequency of each score level of the students, cumulative frequency, and cumulative percentage. Then cumulative frequency presents the number of the students who scored at or below the score in question, while cumulative percentage is the same thing, expressed as a percentage of the total number of the students. The concept of cumulative percentage is particularly important for interpreting norm reference test results. I think that's all. Go to the next speaker.
Next is frequency data. Frequency data can be displayed in far more graphic and appealing ways than the plain one. Ordinary frequency distribution that's shown in this table. Such graphic displays of scores generally come in one of three forms: a histogram, a bar graph, or a frequency polygon. All these three are drawn on two axes: a horizontal line, also called the abscissa or x-axis, and a vertical line or ordinate or y-axis. A histogram of frequencies of a set of score is normally displayed by assessing score values to the horizontal line, abscissa, and putting the possible frequency values on the vertical line. So, an X, artistic, asterisk, dot, or other symbol is then marked to represent each student who received each score, as shown in this figure. If bar are drawn instead of XS to represent the score frequencies, the result is bar graph, like in this figure. And when dots are placed where the top X will be at each score values and are then connected by lines, the result is frequency polygon, as shown in this figure. Okay. All three of these ways of displaying task results are important because first, they can help teachers to understand what happened when their students took a task. And another excellent reason for teachers to understand how such graph work is that such techniques are sometimes used to misrepresent or distort information very greatly. So that's why understanding how graphs work can help teachers to defend their program successfully against harmful external misrepresentations about enrollments, budget, teaching loads, and so forth. And Description of language tasks most often omit these very useful forms of graph. Test developers and test scores users are missing out on one kind of test description that could help them to understand what the score on the test means. Teachers should graph their test result in one way or another and consider what the graphs may be showing them. So fortunately, graphing numbers has become relatively easy in today's personal computer-oriented world. And at the minimum, teachers should examine descriptive statistics whenever they administer a task. Descriptive statistics are numerical representations of how a group of students perform on a task. Generally, test developers are responsible for providing descriptive statistics so that all test result users can create a mental picture of how the student perform on the task. Yeah. Two aspects of group behavior are considered in descriptive statistics: the middle of the group and the individuals. Both are important because the user of the result of the test result must be able to visualize the middle or typical behavior of the group as well as the performances of those students who varied from the typical behavior. In statistical terms, these two aspects of group behavior are called central tendency and dispersion. Okay, in central tendency is the first aspect of task to consider. Central tendency itself describes the most typical behavior of a group. Four statistics are used for estimating central tendency. First is the mean, the mode, the median, and the midpoint. The mean is probably the single most important indicator of central tendency. The mean is virtually the same as arithmetic average that most teachers calculate in grading classroom tasks. The mean is symbolized in writing by X bar. Yeah, X bar. Another way to define statistical concept is to give the formula, like in this figure. This formula is to calculate the mean. And this is the example. Yeah. To find the mean in this example is first we sum or add up the scores, and next we find the number of scores and divide the sum of the scores by the number of scores. So the mean in this example is will be 69. As mentioned before, this set of calculators probably looks very familiar since most teachers use the arithmetic average in looking at the result of a classroom task. What they are checking in the process is almost exactly the same as the mean and therefore is an indicator of the central tendency or typical performance of their class on the task. Second, we have mode. Another indicator of central tendency is mode. The mode is that score which occurs more frequently. In the example before, what would be the mode? It would be 69, the only score received by 4 students. So that's why the mode would be the score which is received by the most students. No statistical formula is necessary for this straightforward idea. However, note that a set of score can have 2 or more modes. Such distribution of score are referred to being bimodal, trimodal, and so on. Next, median. The median is that point below which 50% of the score fall and above which 50% fall. Thus, in the set of scores like 100, 65, 83, 71, 61, 57, and 30, the median is 71 because 71 has the 3 scores above it, 100, 95, and 83, and the 3 scores below is 61, 57, and 30. In some cases, arise that not so clear. For example, in this data, in such situation where there is an even number of scores, the median is taken to be a midway between two middle scores. In this example, the middle scores are 15 and 16. So the median is 15.5. Yeah. So there is more than one numerically equal score at the median. For instance, like this data here, the midpoint is clearly 50 because there is an odd number of like scores at the median, separating equal numbers of scores on either side. The important thing to remember is that the median is the point that divides a score 50 per 50. Much like the median in highway divide the road into two equal parts. And we should sort first the data, from the lowest one to the highest one. However, instead of the test scores, the median may have fraction because students rarely cooperate to the degree that highways do. Next, the midpoint. The midpoint is a set of scores. Is the point halfway between the highest score and the lowest score on the test. The formula for calculating the midpoint is like in this picture. For example, if the lowest score on the test was 13 and the highest one 100, the midpoint would be halfway between these two scores. To use the formula, example, first identify the high and low scores, 100, 130 here, and the low score to be the 1 to add the low score to the high one. 100 plus 13 equals 130, and divide the result by 2, and we got 65. To review central tendency briefly, for such measure exist the mean, the mode, the median, and the midpoint. These are all measures of central tendency, and each has its strengths and weaknesses. None is necessarily better than the others. However, as we will see in this table, for indices for actual task data are seldom so universally well-centered and in agreement on what constitutes the typical behavior or central tendency of a group of scores. For that reason, all four should be used, and the degree to which these four indices of central tendency are similar is one indication of the degree to which a set of score is normally, as in norm-reference distributed. Okay, next material will be explained by my friend.
Okay, next is dispersion. The first one is range. The range is the number of points between the highest score and on measure and the lowest score plus 1. 1 is added because the range should include the score both ends. For example, like if the highest score is 77 and the lowest score is 61, and then the range is 17. The range only reflects the magnitude of outer edges, high and low, of all the variation in scores, and therefore can be strongly affected by any test performance which is not really representative of the group of the students as a whole. The range is a weak measure of dispersion. Because of that, the range is usually reported as one indicator of dispersion and should be interpreted by the test score users as just at what it is, the number of points between the highest and the lowest scores on a test, including both of. The next is standard deviation. The standard deviation is an averaging process. As such, it is not affected as much by outliers as the range. Consequently, the standard deviation is generally considered a stronger estimate of the distribution of scores. This is the formulas of standard deviation. Next is the variance. The variance is another descriptive statistics for dispersion. As indicated by the symbol S, the test variance is equal to the square value of the standard deviation. The variance formula is almost similar to the standard deviation, but without root. The test variance can be easily defined with reference to this formula as the average of square differences of the students' scores from the mean. The test variance can also be defined as the square of the standard deviation or as an intermediary step, the calculation of the standard deviation. Okay, the last is reporting descriptive statistic. First one, what should be included in reporting descriptive statistic? The first one is describe at least two aspects of the result on the test, such as central tendency and dispersion. And the second one is the number of students who took the test, or N, and the number of items, or K, that were on the test. And then the last is how should descriptive text be displayed. Descriptive tests are displayed usually in the form of table. This is the example of the table. How should descriptive text be displayed?